plus 1 by u. What is u? What is v? U is the object distance. Okay. So distance, you know, all of you know the distance of the lens always measured from optical center. Okay. So suppose this is optical center. So object distance is from object to optical center. It is u, and v is your from optical center to that object. Okay. So if you know u, if you know v, by using this formula 1 by f is equals to 1 by v plus 1 by u, you can determine the focal length of this lens. And also, you know, if you remember in class I have discussed, if the object, okay, if the object is placed beyond focal length, it is your focal length from here to here, suppose it is your focal length. Okay, so if the object is placed beyond focal length, image will be formed at that point, that is more than 2f. Okay, more than 2f, and what should be the that is the nature of the image. Nature of the image will be real, inverted, and magnified. Okay, so this thing, so this what you have to do, you have to note this u and you have to note the v for a given lens. Okay, and if you for a suppose particular u, you will get particular v. Okay, you get u, you get v. Using this formula, you can find out focal length. For other thing, for other setup, you have to do the same thing. So suppose you this object you displace by some okay, and after that you will get the image distance. If you note this thing and if you do the calculation using this formula, you will get the focal length. Okay, if you take 3 or 4 of this, and after that you have to take mean. So this mean will actually give the focal length of this given lens. Okay, so it is clear what you need to do. Okay, now we will go to the setup. Okay,
this is a bi-convex lens. As you can see, the thickness of the center of this lens is large compared to the edge. Before starting the experiment, one should know what is the focal length of this lens he is using. Okay, so for this purpose we are using some kind of technique. So look carefully as I am holding the lens and light is coming from this tube light. So the image of this tube light will be formed, okay, at this image plane. So look carefully, around 20 centimeter, a very good image of this tube light is forming. So for our case, the focal length of this lens is approximately 20 centimeter. Okay, and one should get an idea what should be the focal length of this lens, because as you know, for different position of this object, image nature and image positions are different. Suppose for an object placed beyond focal length, that is less than the focal length, then the image will be virtual, magnified, and non-inverted. Okay. In order to start the experiment, we placed a sharp object at 135 centimeter and a bi-convex lens we placed at 85 centimeter. So object distance for this purpose is 135 minus 85, that is 50. So if you look carefully throughout this lens, you can see an inverted image is formed by this lens. Okay, and our purpose of this experiment is to find out the focal length of this lens using UV method. And you got the u, that is the object distance, that is the distance from object to lens, and it is 135 minus 85, that is 50 centimeter. And our purpose is to find out the image plane to determine the focal length or image distance. So in order to find this, we are applying a trick. Okay, so we try to match of these two tip of this sharp part. When they match exactly, then we move our camera or head from left to right or right to left. If we are exactly at the image plane, then these two tips will not change their position. Now look carefully, we are moving our camera, but the position of these two tips are changing, so we are not exactly at the image plane. We try to find out the image plane exactly. That's why we are moving that sharp tip. Okay, so look carefully as we move this sharp object close to this image, so the distance between these are changing. Okay, so yeah, we are almost at that image plane. That's why these two tips are very close to each other. So now we need to move little bit so that we can get exactly the image plane. So look carefully, yeah, almost we got the image plane. Okay, so little bit adjustment is required. Let me check again. I think we got the image plane. Okay, let's check. Yeah, so let's check. As we move from left to right or right to left, the distance between these two tips are not changing, so almost we got the image plane. Now we try to find out what is the image distance, that is distance between lens to that image. Okay, so as you know, the lens is fixed as 85 centimeter as I have seen, and the image is at 50 centimeters. So your image distance is 85 minus 50, that is 35. So we will apply the formula, that is 1 by f is equals to 1 by v plus 1 by u. Since we got u and v, applying this formula, 1 by f is equals to 1 by 50 plus 1 by 35, and f is equals to 20.5. okay, so this is the one reading for this one setup. Next we will change the object distance. We will fix the object in another place, and we try to find the focal, we try to find the image plane using the same technique. Yeah, we have got the position. Okay, so yeah, the tips are not changing as we move from left to right or right to left, so we got the image plane. So we will note down the image distance applying the same procedure and object distance, and we will use the formula. Okay, and we will find out the focal length using the formula. So we will do the same thing for another reading, and we will take an average to get the focal length of this lens. Okay, so that's all for the experiment.